Welcome again, everyone. In this video, we will look into the similarities and differences between a tradition computer like the desktop or a laptop and an edge device. We all know how a desktop or a laptop looks like, and you're probably watching this video on one of them. But do you know how an edge device looks like? Well, it's just a printed circuit board with lots of devices attached to it, and there are tons of them out there. Here, I have shown three that are super popular among the edge device and the IoT community: an Arduino Nano, an OpenMV Cam H7 Plus, and a Raspberry Pi 4. And we will discuss them in a little more detail in later videos in this section. Coming back, now that we know what an edge device looks like, let's compare it with a traditional computer. A computer, whether it's a desktop or a laptop, is a general-purpose machine designed to perform multiple tasks like making presentations, coding, playing games, watching videos, or just browsing the internet. And because of these large variety of tasks, its specifications are highly configurable. If you wanted to play video games, you would probably add a super fast CPU and a GPU. If you wanted to make videos, you would probably want a large hard disk to store all those videos. Or if you wanted to multitask or do office work that required the use of multiple applications, you would want to add more RAM, etc. An edge device, on the other hand, is a specialized piece of hardware designed to do one specific task, and it thus has a very limited flexibility in design. You cannot change the processor or the RAM or the storage on an edge device, though some devices may allow you to add external devices to supplement these capabilities. For example, Amazon Alexa is designed to take an audio input, process it, and then output a response again in audio format. It thus has at its core an edge device with a microphone, a Wi-Fi module, and a speaker. If you wanted it to take pictures of your dog and share it over social media, it wouldn't be able to do that, at least not without redesigning the complete application, both the hardware and the software part. Similarly, for your smart doorbell, or the automatic car parking meter at your neighborhood mall. Your doorbell cannot measure the temperature or pressure of your surroundings or take CO2 readings, and the parking meter cannot do what Alexa does. If you wanted that, again, you would have to redesign, but you couldn't do it off the bat. Let's now compare them from a hardware perspective. Most modern-day computers have a compute speed between 2 and 5 gigahertz, a RAM between 2 and 64 gigabytes, and a hard disk space between 250 gigabytes and 4 terabytes. They will also consume power between 40 and 200 watts. An edge device, on the other hand, has a compute speed between 4 and 400 megahertz, a RAM between 2 and 512 kilobyte, a flash storage between 32 kilobyte and 16 megabyte, and will consume anywhere from 120 microwatts at standby to 40 milliwatts when at full capacity. As you can see from these numbers, an edge device is severely constrained in all these four parameters as compared to a traditional computer. The difference in RAM and storage numbers is particularly huge, with RAM being 125,000 times smaller on average, and storage being 250,000 times smaller. And this is really because we want the edge device to be smallest size possible and consume the least amount of power. If your smartwatch or smart glasses weren't sleek in design or required a change of battery every 2 weeks, they wouldn't be so cool now, would they? Finally, let's also look at a computer and an edge device from a software stack perspective. Broadly speaking, a computer has two parts: the hardware and the software. The hardware is the actual CPU, GPU, and other devices, including peripherals like the mouse and the keyboard. The software is the lines of code that help you perform the function that you want to do on a computer, as well as interact seamlessly with the different devices. This software stack sits on top of the hardware and can itself be divided into three components: the operating system, the libraries, and the applications. The lowermost part of the software stack, the operating system, in itself has multiple pieces of code that look after stuff like process management, memory management, network management, input and output device management, to name a few. This last one, the input and output device management, is the part that interacts with your hardware, like the keyboard, mouse, external monitors, etc. On top of the operating system are lines of code called libraries. The libraries contain code like frameworks for graphics or network operations that help in developing applications by providing pre-written code to perform common tasks. And finally, the application layer represents the actual software applications run by users, such as word processors, games, or data analysis tools. In a desktop or laptop, these layers are usually more complex, supporting powerful applications with extensive functionality. In contrast, an edge device, which operates on a microcontroller unit or an MCU, typically has simpler, more specialized software and libraries, optimized for specific tasks like sensor data processing and basic device control. In fact, in many edge devices, there is little to no operating system. This simplification in software is crucial for operating within the limited processing power and memory space of MCUs, which are common in edge devices for tasks like real-time data processing, close to the data source or the edge of the network. This setup also minimizes latency and reduces the load on main network resources, which is crucial for efficient real-time operations. Hope this video provided you with some tangible points of difference between a traditional computer and an edge device. In the next few videos, we will take a deep dive into edge devices and discuss its various components and communication protocols. See you there.